Hello, I'm Jang of IASA. Today, I'm going to talk about the algorithm. What is an algorithm? We face many problems in life. Even if it is not an academic problem, a method is needed to solve a complex problem. You may have made a diagram to solve a certain problem. That's the algorithm. Algorithms are formalized methods to solve certain problems in various fields such as mathematics, computer science, and linguistics and science. Among them, I would like to explain the characteristic, complexity, and method of algorithm used in mathematics and computer science. When you hear the word algorithm, you might think of something systematic and complex. Algorithms have several characteristics. First, an algorithm has input and output. That is, there is something to solve the problem situation, and the solution comes out through the algorithm. Second, it must be feasible. Algorithms are not ways to solve an unsolvable problem. It should be practical and finite, as it is a process of sophisticated and fast-solving complex problems. Third, it must be accurate. This is where the algorithm has an order. There are sequential steps in algorithm. The steps of the work should be clear and the sequences is established. Otherwise, it is not an algorithm for solving the problem. Finally, it should be general. In science, it is important to try to generalize about certain natural phenomena. Theories are discovered and formulas are made. So is the algorithm. No matter how fast and accurate an algorithm is designed, it is meaningless if the scope of use is limited. Algorithms have something called complexity. Complexity is a measure of how complex an algorithm is. Algorithms are basically used to solve complex problems quickly. In other words, the sooner you solve the same problem, the better the algorithm is. Complexity includes space complexity and time complexity. The space complexity corresponds to the memory efficiency of the computer, and the time complexity corresponds to the computational processing power of the computer. We have to pay attention to the time complexity of the algorithm. 100 million years. It is an unimaginable amount of time. But in fact, an inefficient algorithm may take a time exceeding this number. Algorithms start with input. When the input is n can be various types, such as number of data value, and time. In almost all cases, as the n increases, the time increases. That is, it is complex and time-consuming. Algorithm complexity is expressed on a worst case basis. In other words, if you are lucky, you can find the answer at once by using a certain algorithm. But in a worst case, if you have to use it 100 times, its complexity is 100. There are several types of time complexity depending on n. Constant, logarithm, and exponent, square, and cubes can even be expressed as factorials and combination. All we know is that complexity can be expressed by any mathematical function. Finally, the type of algorithm. There are many types of algorithm, but I know that all problems can be solved in different ways. I would like to introduce some of them. The first is the brute force method. This is, after all, a method of finding the all number of all cases. It is the most reliable way to find the answer, but it takes the longest of all algorithms. For very complex problem, it can take an infinite time. The second is division, reduction method, and a dynamic program. These are ways to solve a big problem after solving a small problem by dividing the problem, solve a big problem. Especially dynamic programming can effectively reduce time complexity because it is designed so that overlapping operations are not duplicated. It has the advantage of being able to reduce a huge problem to an exponential multiple. Third is a greedy algorithm, an algorithm that tries to solve only in an optimal direction at every step can yield a huge time gain. However, the range that can be used is limited because it always follows only the best at the moment. The fourth method is backtracking. Backtracking is useful for solving a variety of huge problems by revisiting what has already been explored when solving a problem. Finally, approximation algorithm and artificial intelligence. By using the approximation algorithm, the exact value is not always known. We can ask the question whether this does not fit the characteristic of algorithm, but it also has to do with artificial intelligence. For example, we can easily distinguish between cats and dogs, but AI thinks inductively because AI cannot think like us. It is always error-prone and seek the closest possible answer. As you see, algorithms have been developed through a lot of research and have become a key factor in inventing technology such as artificial intelligence. Humanity will come up with faster and more efficient problem-solving methods through the algorithm. Computer science and algorithm are advantaging day by day. Advances in algorithm will solve many problems. Thank you for listening.